We're going to be solving this double integral today. We're going to start off by noticing in this double integral, the innermost d is a dy. That's going to tell us what variable we are looking for first, and that is what we are going to integrate with. So notice we see a y inverse. That part is going to be integrated, and we have our integral from 1 to x. That tells us our bounds for the innermost integral here. The last thing that we have on here is this little x inverse, and that part we are actually going to treat just as a constant. And we want to do that when we take our first integral because we are only integrating with respect to y. And so we're just going to pretend like that x inverse is a fixed number of some sort. All right, so let's actually integrate this. We're going to start off by punching in our outer bounds and our outer integral. So we're going to leave that as going to be fixed, and we're going to have the dx on the backside, but we're not going to put that in yet. Our x inverse, like we said, is going to come along for our y. The y inverse, the antiderivative, is natural log of y, and here are our bounds, 1 to x, and then we have our dx. And if you feel better about it, you can put big parentheses in there to help distinguish what is going on in your integral as it is. So let's evaluate that, and then we are going to work with the outer part of the double integral. So starting off with, when we punch in the value x, we get x inverse natural log of x. And then when we punch in 1, we get x inverse natural log of 1. And then we have our dx. Now don't forget, when we take natural log of 1, that is actually equal to 0. So our last term is just going to vanish here. And we have the integral from 1 to 3, x inverse natural log of x dx. Now this part is really nice because now we just have one integral to deal with. We know how to deal with that. And if we look at it, we can kind of see, it looks like a u substitution. And that, in fact, is what is going to happen. So when we do that, remember, for our u substitutions, we want to pick out something that we know the derivative to and something that is going to make our integral a little bit more complicated. And in this case, natural log of x fits that bill perfectly. If you try out x inverse by accident, notice that there's only like 2 elements here, so it's going to be easy to double check and realize pretty quickly if you are off track or not. So our derivative is going to be 1 over x dx, which is the same thing as x inverse dx. So you'll see that when we have our du here, we're going to substitute that in for this piece of our function. And then we're going to have a u is going to be the natural log of x. So that's going to be a substitute there. So we're going to just end up with a u du. Last thing that we want to do is our bounds. In this case, we don't want to necessarily go back. So our old lower bound was 1, which means our new lower bound is natural log of 1. And as we said before, natural log of 1 is 0, so we can punch that in. Our old upper bound is 3, which means our new upper bound is natural log of 3. And you'll notice that if you punch natural log of 3 into your calculator, it's going to come up with some number, and we really don't care what that number is. So we're just going to leave it as natural log of 3. So this gives us our new integral from 0 to natural log of 3, and we are left with a u du, and that's it. When we evaluate this, we are going to end up with adding 1 to our exponent, dividing out by our new power, and we are going from 0 to natural log of 3. Substitute that information in. natural log of 3 quantity squared over 2 minus natural log minus 0 squared over 2. So our final solution is natural log of 3 quantity squared over 2. And there we are. Thank you for listening.